Okay, so let's start with that. So, okay, the question is, what is work done? When you're going to say that you had done some work. So, in the first case, let's suppose I asked you, you are pushing something, and this thing, the block is not displacing. Is it you're doing some work and you're the whole day you're pushing the wall, let's suppose that, and it doesn't move. Is it you have done some any kind of the work? And the next one is, let's suppose right now, if I ask you, is it you're doing any kind of the work right now? You're studying. So, is it you're doing any kind of the work? The moon is revolving around the earth. And right now, there is a gravitational force the earth is applying on the moon, and that is pulling toward that. So, basically, that is centripetal force that is acting here, something gravitational force that is acting towards that one. Is it you are is it the gravitational force doing any kind of the work? Okay, so work done by a constant force. Let's talk about that first. Work done by a constant force. If you have a constant force that you are applying to some block, and is it that doing the work? And how we define in this physics, we define the work done in a very specific way, and that is going to be defined as, let's suppose first I take the one of the example that you have the block and you are applying the force to some specific angle. Let's suppose this is the force that you applied in this, and the block get moved. So the block get moved. So let's suppose that you apply the force and the block moved in the horizontal direction from here to here, and copy it and let me paste it here. So it get displaced from this to this, it get displaced from this to this. This is the actual displacement is. So this is the actually the displacement, how much the displacement that he made it. So this is the displacement. So how we can define it? I'm going to first, I'm going to take the component of the force in the direction of that. Let's suppose this the force is F, I'm going to call it. So with this angle is theta. So if you know how to resolve the component, so I'm going to resolve the force in this direction, that is come out to be F cos theta. So I'm going to take the component of the force in the direction of displacement. So in this vertical direction, there is a F sine theta. Just think it logically also. Is it the force acting that is upward? Is it there is any contribution, or is this force is it possible that this force upward acting can displace it horizontally? No. So we never talked about this force, basically the component, the force that is acting it up. So that is because that is not dragging it the block or the box in the horizontal direction. So we take only the component of the force that is dragging the box in the horizontal direction. So how we define the work done. So if I had to write the actual definition for that one, work done is defined as of displacement. So we are going to be take only the component in the direction of displacement, because this force component only responsible to drag the force in the horizontal direction. So we are going to be take that one only. So work done by F constant force. Right now this is a F, the work done by the force, the F force is equal to F. The parallel component, I'm putting the parallel symbol over there, that is parallel to the displacement, into D, and that parallel component is F cos theta into D. This is the parallel component into D, that is the work done, and the work done I can write like this, FD cos theta. Remember it, work done is a scalar quantity. The unit is the same as the energy unit because energy is ability to do some work. So that's a unit, and we write it with the capital letter G. G. Now you will get the answer for all the question that I asked you initially. First, the question is that I shown to you in this case. You are not any kind of this person is trying to displace it, but right now there is no displacement, so the work done is zero by this person. So this person is the whole day is going to be applying that force, not doing any kind of the work. And if we are studying that, you are sitting over there, you're not displacing, so the work done is still zero. Right now look at this force, the force that is, or the gravity, I would say that the force that is acting the towards that the center of the earth, and this is the displacement, this is the displacement or the motion direction, motion of the displacement direction. What is the angle between them? The angle between them is 90-degree. Work done definition is FD cos theta, and you have that what is cos FD and cos 90-degree. Cos 90 degrees, not 1. This is 0. So the work done, yeah, work done by this one is 0. So gravity not doing any kind of the work done. In this case also, let's suppose the person is applying the force in this direction. So you had to be take only the F cos theta component that is dragging it in this direction. So this is the only the F cos theta component you had to take it, and you had to the work done by this for this person. So basically that is going to be F cos theta, that is the component into displacement. So this is how we are going to take it. So displacement, how much the d value that they given. So this is right. So so right now they are the this person is just holding that one. So this person is not displacing any load. So if you hold that something on the head or something, if you are holding in the hand even, holding, you are not displacing. According to physics, you are not doing any kind of the work done because there is a no displacement. And in this case, let's suppose the person move. So displacement is in this direction, the work done is in this direction, the force is in this direction, sorry. So you are holding that one, and in this case also, this person to move this box, the person, the force applied by the person hand is there is no work done. Even let me talk about the gravitational force. The gravitational force is acting downward and the displacement is in this direction. So still 90-degree. Cos 90-degree is 0. So that is the work done. In this case also, somebody asked you the work done by mg force. In this case is, or gravitational force is also 0. Work done by mg force is also 0 in this case. This is how we define it. Now in this case, what is the friction force direction? Friction force is going to be act in the opposite direction. So friction force that is going to be acting in the backward direction. Right now, the displacement is in this direction. This is the displacement vector. I'm going to call it d vector. And this is the friction force vector. What is the angle between them? If they are opposite to each other, the two vectors are opposite to each other, then the angle between them is 180-degree. So the cos 180 degrees. So if I had to define work done by friction force, So let's friction F force into D displacement into cos 180 degree. And what is that cos 180 degrees? That is interestingly -1. It means that work done can be negative also. So this is negative, I'm putting that, and that is FD, that is the work done by friction force. Work done by friction force is always negative. Please note it down. Work done by friction force is always negative. So this is how you have to deal it. And if somebody asks you work done by mg force, in this case, 0, because 90 degree to the displacement. Work done by normal force, Fn, that is also 0. In this case, because it is normal, is also 90 degree to the displacement. So this is how you had to be think about that in the work done by something. In the according to physics, we define like that. The work done, again, let's recall it. The work done by a constant force. Right now we are defining it. So work done by the constant force, it is the defined as the product of the magnitude of the displacement and the component of the force in the direction of displacement. So this is FD work done, FD cos theta. That is the work done by that constant force. This is how you have to think it. So this is for AP Physics 1 and the 2. And if you have the calculus 1, so let me define according to the variable force also. Okay, so right now, this I'm going to apply the sum of the forces and it is going to be displace that. So the idea here is simple. So if I'm going to displace it, some kind of the work being done by me to displace it. So right now, if I move it right now, as you can see it, I'm applying some kind of the variable force. So this is the way that I applied that. So this is just some kind of the variable force during that motion that I applied. And to calculate that work done, I had to find out this area. Can understand it how to find out this is the force on this axis, this is the displacement on this axis. So how to find out this area under the curve? What you have to do to find out this area, the area under the force time graph will give you the work done. To find it out, that one I had to split into the small parts basically, and this is dx. To displace the block by the very small displacement dx, and this is a force in a variable. As the displacement is happening, the force is a variable quantity. So I'm going to define the work done by that force that applied it is integration of f, force is a function of the x, into dx. We have to just integrate that one, and that is you will get the work done. Thank you. Have a good day.